Right. Now we are learning about what? Connected bodies. Now see here, whether you will be able to see some diagram in this particular slide. Now diagram is there or not here? What you are observing in that diagram, Arnav? Tell me.
Sir, it is a pulley with
Right,
two
very good.
masses.
A pulley is there. And for this pulley, how many bodies were connected?
Sir, two masses.
Two masses were connected. M1 and M2 are connected. And when two bodies are connected like this, in which side this connected bodies will move, and if they are moving, what will be the tensional force in it, what will be the acceleration in it, all those things we are going to learn in this particular session. And suppose let us say here M1 is there, M2 is there. Now M1 mass is larger than the M2. Now observe carefully, M1 is greater than M2. That means this mass is more than this mass. So this is bigger, this is smaller. And these two connected with a string like this. One string is there, and with the string we attached it. Then which side this total system will move? Whether the system will move this side or system will move this side? Or no?
Sir, M1 side.
Which side? M1 side or M2 side?
Sir, M1 side.
Why M1 side it will move?
Sir, because M1 mass is greater.
Bhumika, why it is about second side? First object, no, first object is having more mass than the second object actually. So as it is having more mass to the first side, it will move down, isn't it? Bhumika, is it clear now? Right. So as mass of the first one is more, definitely the system now will move down. When it is moving down, now with what acceleration this first object is moving? Let us say acceleration of the first object is A. Then definitely second object also will move with the same acceleration, but that will be in upward direction. But now my aim is to find out this acceleration value and how I can find this acceleration value, that I am going to say now. And in order to say, now tell me how many forces will act in this connected bodies. How many forces will act? Tell me, what do you mean by weight? What do you mean by weight?
Sir, the force with which the earth is pulling the body towards itself.
Again, or no?
Itself.
Very good. When Earth is attracting any object towards it, that pulling of that Earth will be called weight of the body. So always weight will act on the objects or not? Or no?
Yes, sir.
That will be downward or upward?
Downward.
Very good. Downward, always weight will act. Now observe carefully. Weight on the first object is acting in a downward direction, which is M1G. Similarly, weight of the object M2 also will act in a downward direction. So weight is also a force or not? Weight is also a force or not? Mr. Arnav, weight is also
Yes.
a force or not? Tell me, Bhumika, whether weight is a force or not?
Yes, sir.
right? Weight is also a force. So weight is acting downward direction. When weight is acting downward direction, suppose if you and your friend taking one string and pulling each other, in that string some force will be there or not?
Yes, sir.
What that force will be called? That force will be called tensional force. What that
Tension.
force will be called? Tensional force. And that tensional force in this particular string to this particular first mass will act in upward direction, and to that second mass also it will act in upward direction. So tensional force will be there. Tensional force is there, weight is also there, and due to that it is moving to some side. And then how to find out acceleration of the total system? How to find out the total acceleration of the system? And to find out the total acceleration of the system, you have to find out how much net force is acting on a first mass, and you have to find out the net force acting on a second mass. So let me find out first on a first mass. And on a first mass, how many forces are acting? So let me say like this: F net force on first object will be equal to M1G is acting downward and T is acting upward, and maybe you know that this particular first object is moving downward. When it will move downward, when it will move downward, Mr. Arnav,
So
when it
when
will
gravitation is acting on it,
right. If gravitational force is more, it will move down, or gravitational force is less than the tension, it will move down.
sir, it will move down when the mass of the body is greater than the second mass of the body.
Not that one. You are not getting my question. Here two forces are acting on a first object M1 only. I am taking only M1 object. On M1, weight is acting downward, tensional force is acting upward. It is moving down. It is moving down means weight will be more than the tension, or weight will be less than the tension. Have you got my
Equal
point?
and opposite to the tension.
Equal and opposite. Both will be equal and opposite. If both equal and opposite, whether the object will move to any side,
No, sir.
it will not move. If one is more and other is less, then only it will move, no?
Yes, sir.
Now tell me, this first object M1 is moving down or not?
Yes, sir.
Moving down means weight will be more, or tensional force will be more?
Weight will be
Weight will
more.
be more. When weight is more, then only it is moving down, isn't it?
Yes, sir.
If both are equal, what will happen? If weight and tension are equal, whether this M1 will move down or M1 will not move,
It will not move.
it will not move. As weight is more, that's why only it is moving. So that's why F net force acting on the first object I can write like this. See here. What I can write? M1G minus tensional force. Why I am writing minus tensional force? Because these both are in opposite direction. That's why I am writing minus. If both are acting in a same direction, we have to write plus. So F net force is equal to M1G minus T, and F already you know force will be, I am writing like this, M1A is equal to M1G minus T. So I am writing this as equation number 1. Why I wrote M1A here? Force is equal to MA equation. You only said Arnav, isn't it?
Yes. sir.
Right. So F is equal to m1a. Can I write like that? M1 is the mass of a first object. A means acceleration of that first object. So m1a is equal to m1g minus t. Now similarly, let me write net force acting on a second object. Now tell me, second object mass 2 is moving up or moving down?
Sir, moving up.
Moving up. When it is moving up, uh, generally tensional force will be uh, sorry, I want to find out F not net force, but to find out the net force, try to understand like this. Tensional force is acting in upward direction, plus net force is also acting in upward direction. Why? Because it is moving up. No, as moving up, net force is acting in upward direction only. That's why only it is moving up. So is equal to m2g. These two will give us weight of this object. So I will write like this: tensional force T plus F net on a second object will be M2A is equal to M2G. So if I write M2A is equal to M2G minus T, I can write, I am writing it as equation number 2. Now we have to derive these two relations. That means we have to simplify them and we have to find out the acceleration, and after that we have to find out the tensional force in it, and that tensional force turns out to be that equation, and how we will get that equation I will explain in the next class. Okay, Arnav?
Yes, sir.
Bhumika, is it okay? I'll take permission, special permission. Actually I have to finish fifth session also, but I'll take permission from them, and I'll finish in one more class. Okay,
Okay, sir.
right. So good night for today's session.
Thank you, sir.
Right. Maybe have you understood about law of conservation of momentum or no? Okay. Right, Bhumika. Thank you. Good night.